Hey, there is an interesting pattern in the difference of subsequent squares. Okay, so subsequent squares, what do you mean by that? Like, the difference between 2 square and 1 square, 3 square and 2 square, 4 square and 3 square. Okay, if you try to formulate, let us consider 3 square minus 2 square. Okay, how we can formulate this? If x is equal to, if we consider x as 2, this will become 2 plus 1 square minus 2 square. Okay, so in the same way, any subsequent number, if you consider one number as x, increase it by 1, and the difference of the squares has an interesting pattern. Okay, so this is how we formulate it. Let us see how to understand graphically. Okay, so we this is the formula: x plus 1 whole square minus x square. Okay, so we know that 2 square is 4, 3 square 9, 4 square 16, 5 square 25, and so on. Numbers are unlimited. Okay, uh, here we know that 2 square is 4. How graphically we can represent a square of side 2 will give you 4. Okay, in the same way, 3 square is 9, 4 square is 16, 5 square, here 5 square, sorry, yeah, 5 square is 25. Okay, and what is the difference? What is the difference between these each square? 2 square is 4, 4 minus 1 is 3. Okay, and 9 minus 3 is 9, sorry, 9 minus 4 is 5. So this is 3 square minus 2 square, and 4 square is 16. 16 uh, 16 minus 9 is 7. So this is 4 square minus 3 square. Okay, and 5 square is 25. 25 minus 16 is 9. So this is 5 square minus 4 square, and 36. 6 square is 36. 36 minus 25 is 11. Okay, in the same way, uh, 49 minus 36 is 13. What you can observe, these all are prime numbers, right? First they are odd numbers and prime numbers. Is this trend continues to the next numbers also? May not be. Let us try to understand graphically. Okay, so what is 3 square? 3 square is 9. Okay, 3 into 3 is equal to 9. What is 4 square here? This is 4 square. Graphically you can see 4 on each side. Okay, 4 into 4 is 16. Okay, so how do you formulate this now? 4 square minus 3 square. Consider 3 as x. X plus 1 square minus x square. We know the formula, right? A plus b whole square is equal to a square plus b square plus 2ab. Okay, so x square, that is a square, plus 1 square, 1 square is 1, plus 2ab, 2x, and into 1, that is 2x, minus x square. Okay, we know this x square and this x square, sums to 0, because this is plus x square is minus. So totally, finally what you're getting, 2x plus 1. See, if we go back to this pattern, see here, the x is 3 and the difference is 5. 7. The difference is 7. So um, 3 plus 1 square minus 3 square is 7. Okay. 3 plus 1 square minus 3 square, as per this formula, as per this formula, it should be 2x plus 1. So here x is 3, so that is 2 times 3 plus 1. Okay, so this is 6 plus 1 is 7. So this will continue for no matter what, how big is the number. If you if you add 1 and square it and subtract with the previous number square, you always get 2 times to that number plus 1. So if you try to understand the same thing graphically, let me erase this. Okay, so um, this is 3 square. 3 square is 9. This is 4 square. 4 square is 16. Okay, so the difference 16 minus 9 is 7. So how to actually represent this graphically? You see, once you consider this 3 square, above this 3 square, to get 4 square, what do you need? You have to increase the size of this square by 1 unit on each side. Okay, so what is increased now? This is the increased area. Okay, so 3 on each side is increased. 3 here, 1 2 3, and here 1 2 3. So from 3 square to 4 square, we can see 3 on each side and 1 on the corner. So that is 3 square plus 3 plus 3 plus 1. So that is plus 2 into 3 plus 1. Okay, so this should be 4 square. So this is 9 plus this is 2 times 3 is 6 plus 1. So 9 plus 1, 9 plus 9 plus 1, 10 plus 6, 16. This is 4 square. Okay, in the same way, let us consider for the 5 square. Okay, this is 4 square. Okay, and this is 5 square. Okay, so to understand the difference, um, this is all 4 square. What is increased from 4 square to 5 square? uh, One number increased, one unit increased on each side. Okay, this side 5, and this side, this row, this column. Okay, so what is increased here? 4 square is 16. The shaded area here, it is 4, and here it is 4, and this corner is also increased, right? So that is 4 plus 1, 4 plus 4 plus 1. So 4 square is already 16 plus 2 times 4 plus 1. So this should be 5 square as per our formula, as per our graphical representation. Okay, so 2 times 4 is 8 plus 1 9 plus 16. 9 plus 16 is 25. Interesting, isn't it? So in the beginning we got all prime numbers, but that may not be true for all numbers as you go up in the sequence. But for sure there is one interesting thing, that it's always a base number. Okay, Why it is always a base number? You take any number in the series, number series, you multiply it by 2. So let us consider a odd number. Okay, take some odd number like 17. Okay, you multiply it with 2, that is 34. It's always even number. If you multiply with 2 to any number, you will get even number. Okay, because you know when you multiply it with 2, you have a pair of these numbers. So a pair is always even number, right? So and you're adding one. Which one you're adding? One second, let me draw in a better way. Yeah, this is assume that this is square with a side of 7. You're adding 1 here. Okay, so this the whole this the bigger one is 8 square, right? So this is 7 plus 7 and 1, right? So this extra corner, this 1, always makes the difference an odd number. So no matter how big number you take, like 99, 99 plus 1 square minus 99 square, this is 100% odd number. Okay, so you try for the biggest number you can and then put it in the comment section. And if you have more questions, any type of questions in maths, physics, geography, you can please post in the comment section. I'll try to make a video for that.